Hello everyone, my name is Du Xinyu. The title of my thesis is Outlier Detection in the Bond Market based on propelling dataset. In my presentation today, I'm going to show you my thesis from this four perspective. At first, I'd like to introduce the background of this project. There are two essential concepts which are the European Consolidated Tab and the European Bond Market. As to the Consolidated Tab, it can not only offer consolidated data on volume and price, but provide a more comprehensive understanding of EU trading. To be more specific, propelling uses this kind of data, which all European venues must report for regulation reasons. As propelling requires, the outliers of bond data deserve attention, especially from the perspective of regulators and platforms. Although there has been many literature on time series data and in the financial market, but very few literature have described dealing with outliers in the bond market. Let's now look at the next slide, which shows the aims and objectives of this project. In general, the goal of this study is to identify the bonds that behave incorrectly or irregularly in the bond dataset by using four different methods and evaluation metrics. In this part of my presentation, I'd like to talk about the two use cases, which are based on the best execution and corporate bond data size. The first objective, from the perspective of industrial regulators, aim to detect whether there are abnormal values in both price and volume of bonds. The second one is for the industrial platforms to check if the data sets they provided are correct. To start with, the data visualization for the best execution data size is shown in this slide. It can be seen from the time series plot that line chart has a general downward trend accompanied by constant fluctuations. However, bonds saw significantly more frequently trading during June, with an really large amount of transactions particularly in mid-June. At the same time, two box plots are plotted to give more information. There are no obvious anomalies in the box plots of price, but there exist some outliers with extremely large volumes. Then let's move on to the corporate bond on four platforms. As the scatter plot shows, it gives an overall view of the distribution of individual bonds, but it's hard to compare. When we look at the box plots for price, it is obvious to see that there is almost no obvious outliers on price. However, when we looking at the box plots for volumes, abnormally high trading volumes can be found in almost all bonds. These two figures shows the descriptive statistical analysis on corporate bonds data size. Now it comes to the methods, and in the following few slides, I will introduce these four methods used in this project. The first method is the Mahalanobis distance. The table and graph show the results of the best execution data set. If you look at the scatter plot, you will find outliers at the data points outside the shade. It is clear to see that there are four outliers for this bond, and their index are shown in the table. The table also displays the proportion of outliers for this bond, as well as contamination threshold and evaluation metrics. Similarly, this method is applied to the corporate data size as well. Here only shows two scatter plots of two bonds with the most outliers. It can be seen from the second scatter plot that, except for the huge amounts, very few transactions can also lead to anomalies. For the table, it illustrates the proportion of outliers for each platform. It can be seen that MTS and Bond Vision have a higher proportion, which means it is more likely to have an euro transaction on these platforms. Now we come to the next method, which is K-means clustering. Unlike the former one, this method has a parameter K, which represents the number of clusters. To determine the value of K, the album method is used, and from the plot we can see that the K is 3 for this bond. Also, the scatter plot shows the three clusters in different color. The black points are the center of each cluster, and the lighter blue points are the outliers. As you can see from the apple plot, the parameter for this data size can be 3 or 4, and the table also shows the percentage of outliers on each platform. Now we come to the local outlier factor method. The contamination thresholds are defined to be 0.01 and 0.05. The red dots in the scatter plots indicate the data points that are normally identified by this method. It can be seen that the results detected by this method differ from the previous ones, with the outliers being more concentrated in the middle of the dataset. Similarly, the table shows the proportion of outliers on each platform when K is 0.01 and 0.05 respectively. For the last method, isolation forest, the contamination thresholds are also said to be 0.01 and 0.05. The scatter plot shows the outliers in each case. By comparing the index, the points identified by these methods are significantly different from those obtained by the local outlier factor. Instead, it can be seen that some same points are identified as in the other two methods. For the last experiments on isolation forest, again it is still the platform bond vision with the most outliers. To see it more clearly, the scatter plots on best execution using each method are put together. It is interesting to find that the Mahalanobis distance and the isolation forest have the same results, which are in the red circles. The methods of k-means clustering can identify additional outliers on top of the results of these two methods. However, anomalies found by local outlier factors tend to be very different. In order to verify whether the results on the second dataset are influenced by the different bond data, a further random selection of bonds was tested to compare the results. It can be seen that the proportion of outliers is still higher on the bond vision platform than on other platforms. Finally, based on the bar chart of CPU time, the usage of time is less on the method of the Mahalanobis distance and local outlier factor. Using isolation forest in anomaly detection seems to be very time-consuming in this experiment. Well, for the peak memory, the difference between each algorithm is not very significant. To sum up, there are 5 points of limitation for this project, and improvements can be done on this in the future. First, improvements should be done in querying data using propellant local API. Second, more experiments should be done to compare the effects of different contamination thresholds. Third, establishing a complete scoring system which can tell the researchers how credible the identified outliers are. Fourth, one more use case of repeated execution for bond is worth considering in the future. Last, some other practical methods can be considered and combined in outlier detections in the bond market. That brings me to the end of my presentation. Thanks for your listening.